Hello everyone, and welcome back to my Military World channel.
A modern warship doesn't just carry weapons, it carries systems designed to detect threats before they're visible. Some of these weapons react faster than a human can think. Others operate silently, from positions no one can track. And together, they answer one critical question. How does a ship survive and dominate in modern naval warfare? At sea, distance is deceptive. Two ships can be dozens of miles apart and still be within striking range. The horizon limits what you can see, but it doesn't limit what can hit you. So modern naval combat isn't about visibility. It's about layers. Layers of defense, layers of detection, and layers of attack. And to understand how these ships actually operate, you have to start at the moment where everything goes wrong. At sea level, radar can only detect threats within a limited horizon. That means reaction time is short, sometimes just seconds. So what happens then? Warships rely on close-in defense systems, like the Phalanx CIWS. Mounted on the deck, it continuously scans for incoming threats. If something gets through, it automatically tracks and engages, firing thousands of rounds per minute. But here's the reality. This is not a perfect shield. It's a final layer, a system designed to reduce the chance of impact, not eliminate it entirely. And that raises the next question. If threats can get this close, how are they supposed to be stopped earlier? Stopping a threat at the last second is risky, so modern warships push that defensive line outward. This is where systems like the SM-6 come in. Instead of waiting for a missile to approach, these interceptors engage threats at much greater distances, targeting aircraft, cruise missiles, and even certain ballistic threats. But distance alone doesn't solve the problem, because speed changes everything. Modern threats move fast enough that detection, tracking, and interception all have to happen within a compressed timeline. And even with advanced systems, there's always a gap between detection and response, which leads to a different challenge.
Comes in the past, since we didn't have these resources.
What happens when your enemy never gives you that time at all? Not all weapons are designed to be seen. Some are designed specifically to avoid detection. Sea-skimming missiles, like the Harpoon, fly just above the ocean surface. This allows them to stay below radar coverage for much of their flight. By the time they appear clearly, they're already close, and at that point, even advanced defenses are under pressure. But what's important isn't just the impact, it's the intent. These weapons aren't always meant to destroy a ship completely. They're meant to disable it, take out propulsion, disrupt radar, break command systems. Because in modern naval warfare, a ship doesn't need to sink to be defeated. It just needs to stop functioning.
It's definitely.
But as defenses improve, so do the weapons designed to bypass them. This introduces a new layer of complexity, because now the weapon isn't just fast or powerful, it's adaptive, which leads to a bigger question. What happens when communication itself becomes unreliable? Modern warfare depends heavily on information. Targeting data, communication links, real-time updates. But in contested environments, those systems can be disrupted. Signals can be jammed, data can be incomplete, connections can fail, and that creates a vulnerability. Weapons that rely entirely on external guidance may not function effectively under those conditions. So newer systems, like LRASM, are designed differently. They can continue their mission even when communication is limited. They analyze targets, prioritize threats, and adjust their approach independently. Not without control, but with resilience. Because in real conflict, systems rarely operate under perfect conditions, and the ones that adapt are the ones that remain effective. Everything we've covered so far exists within combat: engagement, defense, strike. But there's another level, one that operates differently. Ballistic missile submarines, like the Ohio class, are not designed for direct confrontation. They operate silently, underwater, and largely undetected. Carrying long-range missiles equipped with multiple warheads, their role is strategic, not to fight battles, but to prevent them, because their presence creates uncertainty. An adversary cannot easily locate them, cannot reliably track them, and cannot assume they are out of range. And that uncertainty becomes a form of control, not through action, but through the possibility of action. Modern warships are more than metal and missiles. They are highly coordinated machines, where crew, sensors, and weapons all operate together. From the phalanx defending against a supersonic missile, to a tomahawk striking a distant target, to a submarine carrying nuclear deterrence. Modern naval warfare isn't defined by a single weapon. It's defined by layers, layers of defense, layers of speed, and layers of reach. Because in the end, it's not just about firepower. It's about who can act first, adapt fastest, and remain effective, even when everything else breaks down.